All right, so one more section in chapter 8, and then we'll move on to something else, move on to 9 from there. So as long as we get finished with this today, which I think we will, Friday will be Hawks Day. Okay, so we'll be good if you want help on Hawks. We can work on the chapter 8 stuff, or we'll work on anything in Hawks. Doesn't matter. That's 3, and then the final's optional. If you want to try to make it, if you make a better grade on the final than you did on one of the other 3 tests, it'll replace the lower grade. Yeah. If you're happy with your grade, you don't have to take the final. Yeah. Yeah. Let you out of here. Everything we go over that class, I'm not about it. Checking it to the test format on my base, I have a test tomorrow. Yeah. And I feel like I'm going to fail that class because of that. Yeah, sometimes you get a little test anxiety and it's tough. So we haven't had too many calculations in chapter 8. Really, we done any yet? Not much of anything anyway. So most of our calculations for this chapter are in this section. Okay, but they're not bad. They're not bad. Okay. Nothing overly complicated or anything. So our goal in this section, we want to be able to analyze and describe our data with a few different numbers. We're going to look at measures of center. Those are mean, median, and mode. Range. We're going to look at standard deviation, but I'm not going to make you calculate it in here. And then we'll look at percentiles and quartiles. So they're not really calculations so much as just organizing the data and picking them out off the list. So nothing too terrible. Okay, but you get a little taste of some of the statistics that we use. All right, so let's look at our first formula. And don't let the formula scare you. And it looks a little intimidating until you break it down. It's not bad. So this first one's what we call the arithmetic mean. You're probably familiar with the calculation. You just probably call it the average. So all we're doing here, we look at the formula and then we'll get back to that. Okay, we're just adding up all the data values we have and dividing by how many there are. So that's typically what people just call the average. Okay. There are several different ways we can calculate the type of number that we would call an average. So we don't just call it the average, we are more specific. So this type of average we call the arithmetic mean. Okay. So mean is our slightly more technical word for an average. And this is the arithmetic mean. One other thing you may remember me saying before is that in statistics we have to be really careful about communicating where our numbers are coming from. Did they come from the whole population or did they just come from some sample data? So here, the way this is written down in the form we would use for dealing with population data. So this symbol, it's a Greek letter, is our symbol for population mean. Anybody know what Greek letter that is? It's lowercase, so you may not be as familiar. If it's with the uppercase, a lot of people will get it from Greek organizations. So that is mu. What I call it is mu. You can either say mu, okay, or you can say moo. Some people call it that too. You just have to make a personal decision if you'd rather sound like a cat or a cow. Okay. But I call it mu, and it's spelled mu. Okay. And when I handwrite one, it looks like that. Okay. So we call our arithmetic mean mu if we got it from population numbers. So again, we just add up all the data values and divide by how many we have. Or if we're dealing with sample numbers, and numbers from sample data, we use a different symbol to represent the arithmetic mean. There we would read this one, it's an X with a straight line over the top of it. Right? There we read that X bar, what we would call that symbol. And it's just X with a bar over the top. So they're the same calculation. Here we're just adding up all the data values, dividing by how many we have. But we give it a different symbol to differentiate when our numbers come from population values and when our numbers come from sample values. So both of those are the same calculation, we just have different symbol. Okay. So let's do one. It's not difficult. Might as well do an example. Okay. Since it says a sample of the number of sick days employees at Witt's Insurance Agency took during last year is listed below. Calculate the mean of the sample data. So since it's sample data, we would call it X bar instead of mu. And then to figure out the mean, we would just add up all of our data. It'll take longer to write it down than it will to calculate. Okay, so we would add all those up, and then let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 data values. So we would divide by 8. Let's see what we get here. Okay, so on this one, I got, let me see if that's the right number. Yeah, so I got 8.875. It doesn't tell us how to round. Typically what we would do is we would round that to 1 decimal place. So we'll call it 8.9. That's the arithmetic mean, or you can just call it the mean, usually. Questions on doing those? I'm not gonna, you don't have to worry about too much about the symbols. Just know that we use different symbols in statistics. I'm not gonna like try and trick you and you accidentally use the wrong symbol, count it wrong or anything like that. So just want you to be able to do the calculation. No questions? All right. So this is the first one of what we call the measures of center. We're trying to kind of communicate where the middle portion of our data set is. Okay, so here, if you look at the data values we had, close to 9, right? It's kind of the middle value we have in our list. So that's what we're after there. So the next number we can use to talk about the middle of our data, okay, is called, let's get past this, the median. And the median is just the middle value, but we have to make sure our data is in order. The fancy terminology here is our data needs to be in an ordered array. All that means is we've got it in order from least to greatest or greatest to least. Either one of those works. Okay. And then we just pick out the middle value, and that's the median. Okay. So to help you remember which one the median is, if you're driving down the road, you know, they got that portion between the lanes sometimes if you have a separated highway. That's the median. We're going to have that ditch in the middle. So median is just the one in the middle number. Okay. All right, so This part's important though. We got to have things in order before we worry about finding the median. Let's practice a little. Two data sets here. It says given the number of absences for samples of students in 2 different classes, find the median for each sample. So before we worry about finding the median, we need to put our data in order. I'll help. Okay. I usually do least to greatest. It doesn't matter for median. You could do big to small. Here's both data sets put in order. And then if we want the median, we want the middle value. Sometimes if the data set's small enough, you can just kind of look at it and see what's in the middle. If not, you can cross a number off each end until you get to the middle. So on data set A, our median would be 6. It's right in the middle. Data set B is a little bit trickier because if we try to find our value that's in the middle, what happens? We have 2 middle numbers, right? So if we start with an even number of data values, then we'll have 2 numbers that are in the middle. And in that situation, what we do for the median is we take our 2 middle values and add them together and divide by 2. So here we would say our median was 7.5. So if you have exactly 1 number in the middle, that's the median. If you have 2 middle numbers, you just add them together and divide by 2. We're doing that, we're just finding the number that's between these two. 7.5 is between 7 and 8. Questions on median? A lot of you have probably seen median before that gets covered. You may have forgot about it, but probably seen it before. Anybody know what's next? We got 3 that go together usually. We got mean, we did median, mode. Yeah, mode's the last one that goes in this group. Okay. So if we talk about the mode of a data set, we're talking about the value that is the most frequent and the one that occurs the most. It's possible to have more than 1 mode, and it's also possible to have no mode in a data set. So that makes mode a little bit trickier than it appears to be just by definition. But it's not too terrible. So if we have 1 data value that occurs more often than the rest, that's the mode. If we have 2 that occur the same number of times, but it's more than all the rest of the data, then we would say we had 2 modes. If we don't have a data value that occurs more than the rest of the data, we would say we have no mode. So let's look at a few. This one says find the mode of each data set, and then I'm not too worried about this next part. It says state if it's unimodal, that means 1 mode. Bimodal means 2 modes. Multimodal would be more than 2 modes, or has no mode. So I'm not too worried about that, because if you give me 1 answer, I know you know it has 1 mode. If you give me 2 answers, I know you know it has 2 modes. So that terminology is not that big of a deal. If we have no mode, I do want to know that though. So let's look at this, and this one's a little hard to pick out because it's words for data. So what's it look like? We definitely have some repeats in there. I think it is violet. I think violet occurs the most. Let's see if we can pick those out and see if that's. So we got a violet here, there, 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 and there. Yeah, I think that. turquoise on there a few times, but it's only like 4 or 5 times, so. I think violets are mode on this one. Okay. So on this one, we would say we have one mode. Our mode is violet. Okay. That's more than any of the other data values on the list. Okay. All right, let's look at B. B, got some football jersey numbers. You see any that repeat in there? I don't think I do. Anybody see anything that beats me either? So what would we say on that one? Yeah, no mode on that one. Okay. What about C? Yeah, I think I agree with that. So we've got 4s on there 3 times and 7s on there 3 times. So what would we say on that one? We got 2 modes. Yeah, our modes are 4 and 7. D's tricky. What do you think on that one? No, you can have as many modes as you want, but yeah, so the thing that makes D tricky, okay, you could think about, now we got 9s on here twice, 13s on here twice, 10s on here twice, 14s on here twice. So you may think we've got 4 modes, okay? But on this particular data set, the issue with that is that every part of the data would be part of the mode. We wouldn't have anything left over that's not part of the mode. So what that makes this one turn out to be is no mode. Okay? No mode. So that one's tricky. So the thing that I tell my stats students to keep in mind is that if once you pick out the mode, you've got to have something left over. Like on this one, we had some numbers left over that were not part of the mode. So if we had like one more number on the list, if we had a 7 out there or something, then we would have 4 modes. And it would be 9, 10, 13, and 14. But since our mode would take up the whole data set, that one's no mode. Okay. So mode can be a little bit tricky, but I'm not gonna try and trick you. So if I ask you for a mode on the test, it's just like one of the first 3. Okay, questions on mode? Not too bad. All right, something else we have to be careful dealing with when we're talking about these measures of center. You may wonder why we have 3 of them, right? If we wanted to talk about the middle of a data set, why don't we just pick one and say that's always going to be the middle of our data set? But it turns out we need all 3 because sometimes one of them works and sometimes another one will work and sometimes a different one would work. Sometimes all 3 are okay. And so there's just different situations. We have different types of data, and for different types of data, sometimes we need a different measure of center, okay, to give us a good picture of what's going on in the middle of our data set. And one reason or one thing that causes that issue where they don't always all work is sometimes our data may have something that we call an outlier, or could have multiple outliers. Okay? So our definition here says an outlier is a data value that is extreme compared with the rest of the data values in the set. Okay. So what do we mean by that? So, all right, maybe we're thinking about the age of students in the class at JSU. So here we got some data here. which one would you call the outlier? $98, yeah, because this doesn't fit in with the rest of the data values, right? So we have different ways we can like measure and think about whether or not a data value is actually an outlier or not. We don't have to get into all that. We just want the big picture here that if we have a data value that has an extreme value compared to the rest of the data values, then we would call that an outlier. Okay. And outliers cause us trouble in several different ways in statistics. And you'll see more about that if you have to take 204. Okay. All right. Let's do this one. This one gives us a data set and it tells us to find mean, median, and mode. And then we're going to pick out which one of the numbers we think gives us the best description of the middle of our data. Okay. All right, so for mean, we add them all up, divide by how many we have. I'll cheat for us a little bit and give us the answer. So if we add all these up and then divide, we have 11 data values, divide by 11, we get 37.4. We want the median. We would have to put them in order first. If we put them in order, we end up with one number that's exactly in the middle. Again, I'm cheating for us. Our middle number for this data set is 26. And we can do the mode. Just looking, let's see, what do we see for the mode? Anything? We do have a mode. What is it? 15. Yeah, mode's 15, I believe. It's on there twice. So. Okay. Which one of these numbers, just from looking at the data set, which one of these numbers looks like it describes where the middle of our data would be the best? Is there one you would throw out and say it's not the best? To me, I think mode doesn't look like it gives a good picture of the middle. 15's on there twice, but it's like one of the smallest values right in our data set. So just no right or wrong here. I'm just asking an opinion. Which one out of these two you think looks like fits the middle of our data better, 37.4 or 26? Yeah, so you can go either way, kind of. So what we would typically do with a data set like this is we would look to see if we have any outliers in our data. 84 is pretty big, but we also have that 77 that's kind of close to it, and then 61. So I don't see any that are real extreme on the small side. So here I would say it probably looks like we don't have any outliers in there. So typically the one we would go with would be the mean in that case. Okay. So then we would say 37.4 would be the middle of our data set. The issue with using the mean all the time is that if you do have outliers in the data set, it messes the mean up. It's going to pull the mean toward any outliers we have in our data. So if we have a really big value, it'll make our mean be too big. Or if we have a really small value, it'll make our mean be too small. So that case where we have outliers, that's when we use the median. And then if we have a situation like the colors of those cell phone cases, right, we can't figure out mean or median in that situation, so we would use the mode. So we need all three of them. We need all three. Okay, so those are our measures of center. Okay. Something else we like to talk about to describe a data set is how spread out our data is. Okay. Are most of our data values pretty close together, or are they all really far apart and spread out? Okay, so one way we can talk about that is using a number that we call the range. I'll get through all this, sorry. For the range, it's really easy to calculate. We just take the biggest data value and subtract the smallest data value. And that just tells us how wide of a range of values our data set covers. For range, it's just the big one minus the small one. Okay, so we can use the range to talk about how spread out our data is. So let's use the range on a couple of data sets here. Just the big one minus the small one, max minus the min, max minus the min, if you want to say it that way. Okay, so A, the number of students enrolled as computer science majors over the past 12 semesters. We want to know the range. So what's the biggest data value in that data set? I think I see 54. And then we want to subtract the smallest. What's the smallest one? Yeah, 5 is, yeah, because we're at the beginning, you can't skip over, yeah, 5. So that gives us a range of 49. Okay. C, you got the numbers of shoppers at a gas station downtown Monday through Sunday 1 week. Biggest one there is 1,054. Smallest is 1,005. So our range on that one, 49. So this example's made to illustrate a point about the range. Would you say those two data sets look like they're spread out about the same? Maybe. To me, I'm kind of thinking not really, maybe sort of, but not really. For sure, they don't look like they're spread out exactly the same. And we get the exact same range on both of these. Okay, so the range can cause us some issues. Okay? It's not super helpful because of situations like this where we can end up with data sets that don't really look all that similar, but we have the same range. So it's a nice, easy calculation. That's good for us here, but for statistical purposes, usually we don't talk about the range that often. If we want to talk about how spread out our data is, we have another number we tend to rely on. You'll notice I have the formulas marked out on this, so don't panic. We're not going to have to calculate it in this class. But our other number we use to talk about how spread out our data is called standard deviation. It's not terrible, okay, but it is a little bit of a hassle. We're not going to mess with it in here. Okay? So the idea of standard deviation is set up to sort of tell us like the average distance a data value is away from the mean, away from the center. So that's what our definition kind of alludes to here. It says how far we can expect a data value to be away from the mean. And again, with our symbols, if we're talking about population values, I'm going to use a Greek letter. You might know what that Greek letter is. This one. Okay, that is sigma. It's just a lowercase sigma. Right? So that one's an uppercase sigma. The one we use for standard deviation is a lowercase sigma, so you probably haven't seen it as often. Okay? It's a lowercase sigma. Okay? So if we're talking about population standard deviation, we call it sigma. If we're dealing with values from sample data, it's a little easier, we just call it S. Call it S for standard deviation. Okay. So again, don't worry about calculating that. We're not going to mess with doing the calculation in this class, so you'll get that in 204 if you need it, if you need 204. But the idea there is that if we have a bigger number for standard deviation, that means our data values are more spread out. Okay? Or if we have a small number for standard deviation, that would mean they're not as spread out, and they're all really close together. Okay? So you'll probably see the term standard deviation now that we've talked about it, and maybe you'll have an idea of what it's mentioned in there. Okay? We're not going to calculate standard deviation, but we are going to use it just a little bit. And we're going to just look at the very simplest version of these problems, okay, for this next thing. So again, don't stress. Don't stress. We're going to look at this thing called the empirical rule. Okay. So what the empirical rule tells us is it gives us a way we can estimate how much of our data falls within a certain range of the mean. So how much of our data is this far away from the mean, how much of our data is this far away, how much is this far away. Okay. So what the empirical rule tells us is that if we have what we call a bell-shaped distribution of our data, and we won't get all into that in this class either, but if we start at the mean, so the mean would be in the center. Right? We start at the mean and we go out one standard deviation. So that's just a number. So the mean plus some number and the mean minus some number, we go out that far. Then we're going to have 68% of our data in that range. Okay? On these other two, we're doing the same thing, but instead of just going out one step on each side, we're going to go out 2 steps, and then we're going to go out 3 steps. So we've got, it's like a 3-part rule. Okay? If we go out 2 steps, 2 standard deviations away from the mean, we'll have 95% of our data in that range of values. And if we go out 3 standard deviations from the mean, we've got almost everything, 99.7%. Okay? So those 3 percentages you'll want to have somewhere where you can use them for the 1 or 2 problems we got using the empirical rule. Okay? They're in the slides though, they're in the slides there. So let's look at an empirical rule problem. Okay? These are not bad, because we're not doing anything overly complicated with it. Let's look at this one. It says, suppose you expect that emergency room waiting times for a local hospital have a bell-shaped distribution. That we have to have that so we can use the empirical rule. Okay? The data have a reported mean of 116.9 minutes, standard deviation of 56.1 minutes. Identify the range of waiting times that 95% of patients are likely to experience. Okay? That would be something good to know, especially if like you're in charge of running an emergency room or something like that. So 95%, if we go back to our empirical rule, okay, so the 95% number we know is going to be within 2 standard deviations of our mean. So we just need to figure out what those numbers would be. So the mean, our center where we're starting, is 116.9. And our standard deviation is 56.1. So if we want to go up from the mean 2 standard deviations, we just add 56.1 to that twice. Let's see what we get. There I get 229.1. Okay. That's what we would expect to be the top on our 95% range. And then we can do the same thing to find the lower number, but instead of adding, we're going to go down from the mean 2 standard deviations. So we'll subtract the standard deviation twice. 116.9 minus 56.1 minus 56.1. There I got 4.7. So we would expect people to have to wait, 95% of people are going to wait somewhere between 4.7 minutes, 229.1 minutes. It's kind of a wide range on this one. That if I'm a patient, that doesn't necessarily make me feel good. You're going to have to wait somewhere between 5 minutes and over 3 hours. Let's see, was it almost 4 hours? That's not real helpful, but that's the numbers we get on this one. Okay. Questions on doing those? So the way I knew to add and subtract that standard deviation twice was from the percentage. So the 95% went with 2 standard deviations on the empirical rule. We wanted to know how long, whether the range of values for 99.7% of people, we would have to add and subtract that standard deviation 3 times. Or if we only cared about 68% of people, we could just add and subtract once, right? 1 standard deviation. I did there. Questions on that one? Didn't think anything quiet today? All right, so winding down here, and we're just kind of skimming over the top of several things in this section. Okay, the next little topic here is what we call a percentile. So percentiles just divide our data set into 100 equal parts. It's 100 like percent. And if we see, sometimes you'll get like test scores and things that'll be given to you in percentiles. So you'll get a score and it'll say you scored at the 84th percentile. So what that means, if we score at the 84th percentile, that means our score was as good or better than 84% of the other people that took the test. So a percentile, we're not going to work with them too much directly. We are going to see a special case in just a second. But it's the percentage of the data less than or equal to a given value. That's what our definition says too, but to me it's a little more confusing the way they word it. They tell you approximately what percentage of the data lies at or below a given value. That's less than or equal to. Percentage of, sorry. All right, so we're not going to worry about just regular percentiles, really, but we're going to see a special case here. And so let's skip over that a little bit. What we're going to spend a little more time looking at are these special percentiles, okay, that we call quartiles. It's a weird name, okay, but we get it from the fact that they're percentiles that divide our data set into quarters. Okay? It divides our data set into 4 pieces. Okay? So since it's a percentile that divides our data set into quarters, we call them quartiles. So the first quartile is the number that's like at the 25% mark, right? 25% of our data is less than that value. The second quartile is at the 50% mark. So if you're at the second quartile, 50% of the data is less than that value. If you're at the third quartile, we're at the 75% mark. So 75% of our data is less than that value. And if we split it up like that, we get 4 pieces. Right? We have 3 quartiles, but we end up with 4 pieces. If we have a number line and we put 3 cuts into it, we get 4 pieces. Or 4 quarters, okay? Or 4 quartiles. One little note, Q2 we've already seen today. We just called it something else. So Q2 is the 50th percentile. So another name for Q2 we've already seen, it's the median, the middle number. So sometimes if people are listing out the quartiles of a data set, instead of calling it Q2, they'll call it the median. So you'll see Q1, the median, Q3. Okay. And so what we want to be able to do is we want to be able to find these quartiles in the data set. It's not hard. If you can find the median, you can find quartiles. Okay. Let's look at a couple of data sets here. So we've got 2 data sets, and we're going to find the 3 quartiles for both of these data sets. One thing to help you remember what to do first, since Q2 is the same thing as the median, if we're going to find the median, what do we have to do with our data first? Before we can find the median, we have to put our data in order. I had to put our data in order. So I had to make sure our data set is in order. I've got both of these in order already, and I also have some more room. We can work. So there they are in order. We want to find 3 quartiles. Okay. And Q2 is the same thing as the median. Okay. So since we've already talked about finding the median, let's find it first. So instead of marking them out, I'm going to underline them so I don't get it where we can't read what the number is. So looking for a middle number for Q2. Okay. So in this situation, I have 2 middle numbers, 70 and 71. So how do we find the median, you remember? We have 2 numbers in the middle, we'll find the average. We add them up and divide by 2. So here Q2, or the median, would be 70.5. Okay. That's 1 down. And then we have a little trick, okay, to find Q1 and Q3. And our trick is that we're going to split our data set into a lower half and an upper half. Okay, so what I'm going to do is I'm going to look at that side of the data set and this side of the data set. Okay, so where our median was, I'm splitting our data set right there. Okay. So since we've done that, Q1 is just going to be the median of the lower half of the data, and Q3 is going to be the median of the upper half of the data. Okay. So looking at that first set of parentheses, the median of this lower half of the data, 65. So Q1 is 65. And median of the upper half of the data is 78. So Q3 is 78. Not bad, right? Okay. So on this particular example, we started off with 2 numbers in the middle for our median, or Q2. Okay. Let's look at the other example, because on it, we don't have that same situation. Right? We really don't have 2 situations. So this one, or one like this one. So we want to find 3 quartiles. So I'm looking for Q2 first, the median of the whole thing. So we mark off the same number of values on each side. Q2, we have one number in the middle. It's 75. Okay. We just have one other little trick here. So we're going to still split our data into a lower half and an upper half. But this time when we do that, since we've already used that particular value of 75 for Q2, when I split my data set, I'm not going to include that value anymore. Okay. I'm going to leave it off the list. And now finding Q1 and Q3 works the same way as the last time. Median of the lower half is 67, it's Q1. Median of the upper half is 79, that's Q3. There are our quartiles. Almost finished, almost finished. One other little thing to mention here. Usually if we're figuring out the quartiles of a data set, we don't just show the quartiles. Usually what we will give for a data set instead is something called the 5-number summary. So you want to know what numbers are in the 5-number summary. So if I ask you to give the 5-number summary of some data set, you can do that. It's a good guess since we just talked about them. The 3 quartiles are on there. And then we also want to know the smallest value, so the minimum, and the biggest value, so the maximum. So if we take the minimum, the maximum, and the 3 quartiles, that's what we'll call the 5-number summary of a data set. Well, it won't take but a second. Let's go back and complete our 5-number summary of the last 2. So here, if we want the minimum, that's 59. And the maximum is 85. So those 5 numbers there, we would call the 5-number summary of that data set. We can do the same thing for the first one here. So our minimum on the first one is 60. And the maximum was 81. So there's our 5-number summary for that one. 60, 65, 70.5, 78, 81. Okay. All right, questions on those? Anything? How many of you have to take statistics? Do you know? Have to take 204, a few of you? Maybe some of you do? Yeah. Yeah, that gives you a head start on some of the topics out of there. It won't be the first time you've seen them when you get there. So, okay. All right, that's it for today. So Friday will be a Hawks Day. I'll send a reminder on Canvas. Okay. If you didn't sign the sign-in sheet, make sure you get on there before you leave. Okay, no problem. Yeah, it's no problem.